Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA.
First, let A be a matrix, okay, of order n. This means it is a square matrix, first of all, okay. And lambda is a scalar, okay. And there is an x which is equals to x1 up to xn. So this is a column vector or column matrix of n entries. Then consider the equation. Ax equals to lambda x, okay. So you need to find some lambda and x both which satisfies this equation, okay. And clearly x equals to 0 is a solution, because of course it will happen. Like lambda is a scalar, if you multiply it by 0 it will be 0, and whatever the matrix A be, if you multiply it by x it will be 0, so it will satisfy. But our aim is to find another solution of this, okay, which can give me a different x and a different lambda, okay. So how can I do that? Okay, so let's write it down in this way. Ax equals to lambda x, okay. Then Ax minus lambda x equals to 0. Then if you take x common here, then it will be A minus lambda I into x equals to 0. Okay. So you know, if you want to find the solutions of x, and apart from 0, if there is any other solution or not, you know that this determinant of this matrix should be 0.
Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI MStat, and CMI MSC Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
Now we need to solve it for x, and if we plug the value of x here in this equation, we can find different x's and the space of x we can find. Okay. So let's take a problem and solve. So it will be easier. So actually this is called the characteristic equation. Determinant of A minus lambda I is the characteristic equation of a matrix. Okay. And characteristic polynomial, whenever we will expand this thing, it will become something in terms of lambda. So that will become characteristic polynomial. Okay. So fine. Okay. There are many theorems. I'm not going to prove that, but let me take an example. Yeah. Okay. Fine. Fine. So this is a matrix A. Okay. And we can directly write that 3 minus lambda 1 0 0 3 minus lambda 1 0 0 3 minus lambda equals to 0. Okay. And you don't need to do any row operation because already it is lower triangular form. So just expand it. It is a simpler example, but you could have done something else as well. So that is 3 minus lambda into 3 minus lambda square minus 0, 1, 0, 0, 0. Yeah, just it will be this. So 3 minus lambda square equals to 0. Okay. So lambda equals to, sorry, not square, cube. So lambda will be 3, 3, and 3. Because cube, so 3 times. Okay. Sorry. And if you plug this value of lambda in the solution, then your a minus lambda I of x equals to 0 will become 3 minus lambda is 0, 0, 1, 0, 0, 0, 1, and 0, 0, 0. Clearly, this matrix has rank less than 3. That is less than the full rank. Okay. Into x1, x2, and x3 equals to 0, 0, 0. Okay. So now we will find some x which satisfies this solution. Okay. So how do we do that? So number one observation, x3 is always 0. Because if it is something else rather than 0, this will be inconsistent. The augmented matrix, the rank will be more than the actual matrix we have mentioned in the last class. Okay, so x3 will always be 0. And what about x1 and x2? So basically this is boiling down to x1, x2. So this will be weight. Okay. So fine. Fine. So from here, you can see that like, sorry, like x3 is 0, it's fine. Okay. Oh, sorry. What I'm doing. Sorry. Okay. So if you just multiply this, the matrix, so x1 into 0, x2 into 1, and x3 equals to 0, and x1 equals to 0, x2 equals to 0, x3 equals to 1, 0, x3 equals to 0. Okay. So these two are mandatorily 0. But your x1 is a free variable. Like it can take anything. Okay. So valid solution, one of the valid solutions will be 1, 0, and 0. But one can take any value in the real number, in a real line. Okay. Like not 1, sorry, x1 can take any value. x1 belongs to R. Okay. And as there will be infinitely many solutions, you know, so you can write this solution in terms of, say, x1 is taking some value k, which is in the real domain. So k of 1, 0, 0 will be the solution. And this is a set of eigenvectors for my matrix. Did you get me?
To book a trial class for your preparation courses of Eigen MS, ISIM Stat and CMI MSC Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.